All right, so do you know what scatter plots are all about? What are scatter plots? Okay, and what are these little dots? Where do we get these individual points? From a data set. Maybe it's from some sort of like observation. Maybe we were like timing how fast kids can do like multiplication tables, or how fast people can run, or how long it takes, whatever, like for caffeine to leave our system or something, right? These are all data sets. Now, is this point right here that I'm making right here, is that a real point? Is that from our data set? No. There is a value to that point though. What's the value to that point? Well, it's technically 6.8-ish, comma 2. Well, what is the point to that point? Good. Yes, it's a predicted. So the whole point of these scatter plots is that, or line of best fit, is it allows you to make predictions on values that you may not have data points on. And the more points you have, the more accurate your predictions will be. Okay, so to find the equation of this line, well, there's an Algebra 1 lesson that's like basically the same thing. So that's like, all right, we have a point that's 0, comma 7, and then you have another point that is 8, comma 1. Okay, right. So you get your slope. So that's x1, that's y1, that's x2, that's y2. So you go m for slope equals y2 minus y1 over x2 minus x1. Okay, so y2 is what? 1 over, yeah, and then I would definitely label these points up high like this. You have to be like on careless error high alert, you know? And so when you do these types of problems in our heads, sometimes we kind of mess up and we're like, do it fast, and we're like, you know, 1 minus 0 kind of a thing. So, so okay, what do you have after that? Okay, which reduces down to what? All right, -3 over 4. Okay, so now there's a couple ways of doing this problem. So we have a slope, which is -3 over 4. We also have a point, which is 8. And we have a y-intercept. Well, I'm gonna do different way. I'm gonna do different ways. All right, so we're gonna use, the first way we're gonna do it is the way that what was my go-to way when I was in school, which was you just go y equals mx plus b. And you know when you make these little t-charts and you plot values, like for instance, if you plot 8, right, you're going to get 1, right? So 8 and 1 exist on this line. These values, this y and this x, are represent an x and its corresponding y. Well, this is an x and this is its corresponding y. There's infinitely many of them, but we know 2 of them. We know this one and we know this one over here. Okay, so we could plug it in. So we're going to get 1 for our y equals m, which is our slope, x plus the b, which is what we're looking for. Okay, then we have 1 equals -3/4. Look, I'm doing nothing. Hold on a second. I was rewriting the problem. Wait. So what are we doing? Wait, I didn't plug in my 8. Yeah, wait, let's plug that in right here. 8 over 1. Okay, so wait, we get 1 equals what? What am I doing? Wait, 8 over 1. -24 over 4 plus b. Okay, so, okay, that's good. Go plus 6. All right, and then we have 7 equals b. Now we can actually put our equation together again. So you write your generic y equals for sure our slope. Go ahead. Yeah. And that's the equation. So you just leave y as generic and x as generic. So that way, if you wanted to, you could find other data points around the line, and then you have your slope and your y-intercept. So that's one way of doing it. The easiest way of doing it actually is straight from the graph. And so by looking at it, because if we look at it, we see, hey, we know the y-intercept. The y-intercept is 7. So we know, here, let me kind of minimize all this stuff. And sometimes on the test, like it will be as easy as looking at the graph. Sometimes it won't. Yes, there is. I'm going to show you. Okay, so here you have your y-intercept, which is we have our b, which is 7, right? And then you can also just count. So 1, 2, 3, 4, 5, 6. All right, that's plus 6, and then negative 1, 2, 3, 4, 5, 6, 7, 8. All right, so our slope is rise 6 and to the left 8, but then the negative floats to the top. The plus is invisible, so that's really negative 6 over 8. Chop them both in half, negative 3 over 4. Now you can put it together. You can get this. You can now get, your y equals negative 3/4 x plus 7, right from that. Okay. Yeah, so if you don't have the y-intercept, and also if you could also kind of be clever about your slope as well. So you don't have to use those 2 points. You can say like, all right, where does it cross the grid? It crosses the grid right here, and where else does it cross? Well, it crosses right here. So if I go here, I can go 1, 2, 3 plus 3 over 1, 2, 3, 4. Because the slopes have the same proportion. But you got to make sure you're crossing the grid. You're not going to use points like, like that, or yeah, like in the middle, like I keep doing a good one, like that. You want to hit the corners of the grid. Okay, the other way to do it is knowing the point slope formula. And the point slope formula, it used to be hard for me to remember until I realized something, that I know this formula. M equals y2 minus y1 over, where's our slope formula? Okay, now if I want to multiply both sides to get rid of my denominator, I can multiply both sides by x2 minus x1 over 1. And then over here, x2 minus x1. Then I can wipe. Then I can I'll put the m in the front right here, m, and go y2, make sure x2 minus x1 equals y2 minus y1. Then I'm going to flip, that's really ugly, and then equals y2 minus y1. Then I'll flip it around to get y2 minus y1 equals m times x2 minus x1. Then if I want to, I can erase the 2's and go y minus y1 equals m times x minus x1. That is the point slope formula. That, well, because when you have the 2's here, these represent the second y value of a coordinate. But this guy is generic y, and this is its corresponding generic x. And this is an actual y value, and this is its corresponding x value. So when you have y equals mx plus b, so these are generic. So like let's say I have like y equals 2x plus 7. This y and this x, so those are generic. That could be any x and y, right? And then you plot points into them. So same thing with these green ones. Those are generic. So my observation was on this annoying formula was that it's actually related to the slope formula. You see? It's the same formula actually. So And the way it works is you have to have a point. So you pick a point. I'll pick 8 comma 1. It has to be a point on the graph. 8 comma 1. And you have to have a slope. That's why it's called the point slope formula. Point. So we know our point. Yes, that's right. I used to call it the useless formula, but now I have to show it some respect. The one that's actually useless is standard form. That one gets no respect. That one, that one has to sit at the kids' table. Okay, so we have, um, wait, our slope is, what was our slope? Negative 3/4, right? Yeah. So then y minus 1, just kidding. Oh yeah, that's right. Equals, go ahead. Hmm. Good. And this, believe it or not, is the exact same equation as this. And and what's kind of weird, if you go ahead. Wait, wait. Before we do that, I want to do it with the other point now. So let's do it. Let's do it with. So here we did it with 8 comma 1, and we did it with our slope of negative 3/4. And then here I want to do it with the other point, which is 0 comma 7, and the slope is negative 3/4. Okay, let's just go right to it. So, oh, by the way, just before I forget, if you're going through the whole safe zone process, if you ever have to look up a formula, it's disqualified for safe zone. Do you understand? Still do your 4 in a row, huh? Just you have to mark it safe zone attempt wrong, right? If in but if you think that you can't, yeah, but just still do your 4 in a row. But so whenever you do problems with formulas on your, you should always recreate the formula with every problem. Don't put the formula down on a piece of paper and refer to that for all 4 in a row. You should be like, um, yeah, you should be writing SOHCAHTOA on your paper every single time. You should be writing the quadratic formula down every single time. Because if you're not doing that, you're extending your rounds. You've increased your chance of getting it wrong next time. So, but if you actually have to work a little bit harder and recreate it every time, you're more likely to remember it the next time. Yes. So just cover that up and put it down. All right, so we have y, go ahead, y minus 7, times x minus 0. I'll just put it there. Okay. All right, so over here, what do we do on the left? Over here. No. Yes, distribute the negative 3/4. And then what do you get when you do that? Okay, that's cool. Which is what? Perfect. Okay. Now what do we do? You get the slope-intercept form. Standard form is this form. It's ax plus b, ax plus by equals c. And you often see standard form when you're doing like elimination or substitution, when you see them stacked on top of each other. But standard form sucks because you're not really looking at the slope, but you feel like you are, but you're not. That's not the slope. Yeah, you don't. So, kids table. It's grounds. Okay. All right, so now what do we do over here? All right. And I'll leave that out. I'll leave the plus zero out. Okay, so, and there you go. So even though this, so like if you were doing a point slope formula problem, like in an algebra class, this would be an acceptable answer. And this would, where is it? This would also be, no, actually, it would be up here for this one. This would be an acceptable answer. Either one, I remember like kind of being confused, like they're both right. So they're two different numbers. What's that? Yeah, so when the teacher's grading like a test, the teacher actually has to be aware of both answers because either one of them is right. And you'll know that because when you go this way, when you take it down to slope-intercept form, you get to the same equation. And that's how you do that. Any more questions on this one?